This is Unit 8, Solutions and Solubility. Lesson 5, Colligative Properties. How does adding a solute affect the boiling and freezing point of a solution? The objectives of this lesson: I can determine the effect of adding solute to a solvent on its boiling point and freezing point. I can compare the boiling point and freezing point of a solution to that of pure water. And I can determine the effect of concentration of solute particles on boiling point and freezing point. So do now. So colligative properties are defined as a property that depends on the concentration of the solute particles and not their identity. So what we'll see is the boiling point actually increases when solute is added. So for example, when we add salt to water, this can allow you to boil pasta at 102 to 103 degrees Celsius. So by adding a solute to our water, our pure water, we increase the boiling point. And the reason why is because as we add more things, that creates more forces for us to break, and therefore it's more difficult to boil that water. It requires more energy. In contrast, the freezing point decreases when solute is added. So that's why we put salts on roads, because this causes the ice to melt because it drops the freezing point below 0 degrees Celsius. So when they put all that salt out on the road during our snowstorms, it's because it makes it so that it will melt even when it's really cold out. So the temperature of water typically freezes at 0 degrees. However, when we add salt to it, we can lower it as much as negative 20 degrees Celsius. And that's also the purpose of antifreeze in your cars. So the way I think of it, the more particles we put into something, the greater the effect on the melting point and the boiling point. So that's why we have to recognize when we add something to water, how does it break apart into its component parts? So a molecular substance or a non-electrolyte, when I dissolve it in water, it's going to remain in one particle. So this CH3OH aqueous, that'll just be one piece. Sodium chloride is an ionic substance or an electrolyte. When I dissolve sodium chloride in water, it breaks apart into its two component parts, the sodium ion, Na plus, and the chloride ion. So that makes two different particles. Uh, Sodium carbonate is also an ionic compound. However, it breaks into three parts, because notice how I have two sodiums here. So for every one sodium carbonate, I'm actually going to get two particles of sodium ion, and one particle of carbonate ion. Therefore, I'm going to have a total of three particles for each one. So as I increase the particles, I'm going to increase that effect on my melting point and boiling point. So the reason we do this is we can we salt the icy roads. We're actually going to use this property at the end of the year to make some ice cream. And the antifreeze in vehicles can help keep them from freezing. So one example with you, which compound, when dissolved in water, will have the highest boiling point? So we're going to look at these the way they are, and I'm going to tell you, you need to look at them and break them apart into their pieces. So calcium chloride, this is going to make three particles. Sodium chloride is going to make two particles. C6H12O6 will make one because it's a molecular substance or a non-electrolyte, and sodium iodide will make two. So the one with the highest number of particles in this instance is which one will have the highest boiling point. So you try, stop and think, and check your understanding. So now you can determine the effect of adding solute to a solvent on its boiling point and freezing point. You can compare the boiling point and freezing point of a solution to that of pure water, and you can determine the effect of concentration of solute particles on boiling point and freezing point.